So this video is about ship handling simulation in various maneuvering scenarios. So what we will see here, this is actually a simulator based, and nowadays we have very good simulators to get all the condition of the ship and put in all the parameters of the sea and waves and swell and all the 6 degrees of freedom, and we can get actually how the ship will behave. So many simulators are there, as you all know. Very costly maneuvering simulators are there for the training of, especially masters are doing this ship maneuvering simulator course also. So also we see that so many accidents are taking place because of human error maneuvering. So we need to have a very professional attitude towards maneuvering, and what you call we should know the hydrodynamics and degrees of freedom and different forces and factors affecting the real situation in the ship's maneuvering. So we should always, as whenever possible, note all the data, see, and if possible, try to get a chance to maneuver the ship so that we can improve. So let's see the first condition here. This is a right-handed propeller ship, which is approaching a ship which is on the port side. Its condition is no wind, no current, and it's a single right-handed propeller. Now we will use the transverse force effects, transfer thrust effect, while reversing engine to swing the stern to port. What is the transfer thrust effect? We will see in the next video, but just to mention that if it is a right-handed screw, it will push the water this side, and bow, stern will go towards the stern and bow will go towards the port. Same is opposite when you are giving a stern, the stern will go towards port and bow will go towards starboard. So we'll approach like this, give a stern, bow will go to starboard, ship will become parallel, and we will go like this. So what are the steps for maneuvering? When we are navigating here, when the ship was here, navigate the ship to approach and the berth at an angle about 25 degrees on the port side, and engines will be dead slow ahead. Now we'll keep on moving at very slow speed towards the ship, towards the jetty, and when we see that the vector of the ship, we are around as per the ship's stopping distance when the ship will stop. So suppose here we see that if we give stop engines here, the ship will stop here. That time we will give stop engines. It will depend on your maneuvering characteristics and stopping distance and your loaded and ballast condition. On the approach, taking account of the headway and that the vessel will proceed. So how much will be our headway? As for that, we will stop engine. And then when we reach very close to the jetty, we will give a stern engines, and the as we saw, the stern will go towards the port and bow will go towards the starboard. Ship will become approximately parallel, and then we will pass the lines and do the mooring wherever possible. So mooring pattern, generally without current and wind, there is hardly we can choose any mooring pattern. It means whichever lines you can give first, and that will be as per the winds and north. But since there is no wind and current, so as per the passing wheels and size of the vessel, we can decide the mooring pattern. So here we can pass the head and stern lines initially also, or spring lines also. So let's see the steps in summary quickly. First, move head around 25 degrees to the jetty on that slow head, and stop engine as per the headway when you are going to stop. Then give engine astern when you are very close. The ship will go port side from the stern and starboard from the head, and you can berth parallel to the jetty and keep the lines. So your ship is berthed. But remember, all ships behave differently. So we have to know what is our ship. So let's see the scenario. This in our model is a container ship. Is 110 into 3 meters. It's a fully loaded condition and single right-handed propeller. Draft is 3 meters. And so again, same scenario, berthing port side alongside, but now we will see all the parameters. So you see this ship is, the first step is approaching on dead slow ahead with this RPM and speed is around 1.7 knots. And this is the vector it will reach. So when we see that if we, this is, if we stop, the ship will reach to the jetty. So we do stop engine and still the ship is moving at 1.9 speed ahead. So the speed is reducing, RPM is 0, and we will keep approaching. Now tell me when we will give a turn, when we will see that we are very close to the jetty and we need to turn the ship. So this is a professional judgment which will depend on ship to ship. The ship is you can see is continuously approaching, and you can see like the speed can keep at least around less than 1 knot when you are very close, because there will be speed of current and all also which is not here, so that will keep changing the direction also. So now we are very close, and once we reach very close we will give a stern, and then you will see that the stern is going to port and bow is going to starboard, because this is a right hand screw. When it is moving ahead, because it is moving right-handed, it will give a force transfer thrust here, and stern will go towards starboard and bow will go towards. Same, it will happen opposite when it is going to astern. It will push the propeller will go this side. It will push the stern this side, creating a transfer thrust this side, and bow will go to starboard. So that's what the bow is going to the starboard, and we have given stop engine. And then once the ship is parallel, then we will start doing the berthing.